Researchers at Draper Laboratory in Cambridge, Massachusetts and MIT have developed the first nanosatellite to search for Earth-like planets outside our solar system. The nanosatellite, called ExoplanetSat, is the size of a loaf of bread and packs powerful optics and new control and stabilization technology.
We're working on the prototype, which we plan to launch in 2012 or 2013. ExoplanetSat will go into low Earth orbit and look at a single star looking for an Earth-sized planet in an Earth-like orbit. Eventually, we plan to launch many ExoplanetSats to have a fleet of nanosatellites up there surveying the nearest, brightest sun-like stars for other Earths. ExoplanetSat is looking for a kind of planet we call transiting planet. Transiting planets go in front of their star as seen from Earth, and they cause a tiny, tiny drop in brightness of the star as they go in front of the star. All planets are orbiting their stars, but only some of them, a small fraction, go in front of their star as seen from Earth. Those are the ones we're looking for because the so-called transit technique is the only one today that can find small planets the same size as Earth.
The exoplanet satellite has a volume of 3 liters. It's 10 centimeters tall, 10 centimeters wide, and 30 centimeters long.
There is basically, you can look at it as 3 segments of the spacecraft. And one part, the front part, which we call the observatory or the imaging aspect of it, there is the electronics, or as we call it, the computer systems, the power systems, and the third one is the reaction wheel aspect of it. This part, the reaction wheel, is COTS, that means commercial off the shelf, and we purchased. The avionics aspect of it was custom designed by MIT and Draper. Some parts are bought, but a lot of stuff is customized specifically for this mission. And the heart of the spacecraft is the observatory and basically the science payload. And over here, and if you can look a little bit from this segment over here, is a piezoelectric stage. And this is the heart of an enabler aspect of this technology. What it does, it stabilizes the imaging platform. It moves in 6 degrees of freedom. So if you think about it, it's a plane and you have imagers on it. So if the spacecraft is moving in one direction, what it is compensating in 6 degrees of freedom in order to be locked on the same star. So if this is the spacecraft in here and I have another plane, which is my focal plane, what it does, it will always have a lock directly on the star, regardless of the motion of the spacecraft itself, which enables us to do the science. And that is the basically differentiator and the value added in this form factor.
The goal of the mission is to find Earth-sized planets using ExoplanetSat and later on characterize those planets with a different space telescope to find out if they really are Earth-like and could support life.